Hello everyone, here's a question from electrochemistry. At 298K, the standard electrode potentials of 4 different electrodes are given. On the basis of standard electrode potential, predict which of the following reaction cannot occur. First of all, are the standard electrode potentials given here are reduction potentials or oxidation potentials? They are all reduction potentials, isn't it? Copper 2 plus is becoming copper. That means copper 2 plus is gaining 2 electrons. Only if it gains 2 electrons, then only it can become copper. So therefore, standard reduction potential is what given for everything. Zinc 2 plus becoming zinc, Fe2 plus becoming Fe, Ag plus becoming Ag. Let me just write the value. Now we know one thing for sure is that if the standard reduction potential is high, positive high value, that means it wants to be the cathode. That means it wants to get reduced quickly, isn't it? So if we are connecting silver electrode with any of these electrodes, obviously which one would be the cathode? Silver electrode will be the cathode, isn't it? So therefore, let us look at reaction 1. In reaction 1, we have copper sulfate. So here copper is in +2 oxidation state. We have silver solid, therefore 0. Copper sulfate Cu2 plus is becoming Cu. That is reduction, isn't it? Cu2 plus becoming Cu is reduction, and Ag0 is becoming Ag plus, that is oxidation, isn't it? Now if we are connecting copper and silver electrodes in the direction of the spontaneous change, then we can write the cell notation this way: copper 2 plus, salt bridge, and then Ag plus becoming Ag. Why I wrote this way is because if we are connecting copper and silver electrodes, obviously silver electrode will be the cathode. Copper electrode has to be the anode, because if we are comparing the values 0.80 versus 0.34, 0.80 is high. That means that wants to be the cathode. So therefore, this is the way we can write the cell notation, which means what? Which means at the cathode reduction is happening. This is cathode, this is anode. Whatever be the cell, at the cathode it is always reduction, at the anode it is always oxidation. Therefore, E cell standard is equal to E cell standard of the cathode, that is reduction potential. Standard reduction potential of the cathode minus standard reduction potential of the anode. So cathode minus anode, 0.80 minus 0.34, that would be plus 0.46 volt. But in the reaction, is it given that way? No, it is not given that way. It is given in the opposite way, isn't it? If we are writing net reaction for this cell notation, how we can write? At the anode oxidation happens, so therefore copper solid losing 2 electrons and becoming copper 2 plus. At the cathode reduction happens, Ag plus gaining an electron and becoming Ag solid. We have to multiply the entire reaction, whatever is happening at the cathode, by 2, because 2 moles of electrons are involved, so that we can balance it, which means the net reaction is copper solid plus 2 Ag plus giving copper 2 plus 2 Ag solid. This is possible, isn't it? In the direction of the spontaneous change, this is possible, because when E cell standard value is positive, delta G standard would be negative, because delta G standard is equal to minus NF E cell standard. So only when the E cell standard value is positive, delta G standard would be negative. but that is not what is given in reaction 1, isn't it? The opposite of what is happening at the net reaction is what is given in reaction 1, which means if somebody wants this reaction to occur, then we have to work against the intrinsic standard reduction potentials. That means we have to apply external voltage, isn't it? Because this is not in the direction of the spontaneous change. So therefore, this reaction cannot occur, which means option 1 is correct. For the other three things, I am just going to write the cell notation and calculate the E cell standard. Everywhere it would become positive, and we can clearly see that they are feasible. That means they are written in the direction of the spontaneous change. The reactions are written in the direction of the spontaneous change. For example, for reaction 2, we can write the cell notation this way: zinc, zinc 2 plus, and then salt bridge, copper 2 plus, becoming copper solid. So therefore, E cell standard is equal to 0.34 minus 0.76. Therefore, this is equal to plus 1.10 volt, which is possible. This means here what is happening? At the cathode, reduction happens. Copper 2 plus is gaining 2 electrons and becoming copper solid. So let us look at the reaction. Copper 2 plus gaining 2 electrons and becoming copper solid. So therefore, this is possible. Likewise, we will check for the other two things as well. We are connecting iron and copper electrodes. So therefore, we can put the cell notation this way. Here E cell standard is equal to 0.34 minus 0.44 volt. Therefore, this is equal to plus 0.78 volt. Here also copper 2 plus gaining 2 electrons and becoming copper. Copper 2 plus gaining 2 electrons and becoming copper. So therefore, that is also okay. And then finally, we have zinc and iron electrode. So zinc 2 plus, salt bridge, and then Fe2 plus Fe. So here E cell standard is equal to cathode minus anode. So therefore, minus 0.44 minus 0.76. So therefore, this would be plus 0.76 minus 0.44. So therefore, 6 minus 4 2, 7 minus 4 3. So therefore, this will be plus 0.32 volt, isn't it? Therefore, this is also spontaneous. Here Fe2 plus is becoming Fe at the cathode. We have Fe2 plus, that is becoming Fe. Therefore, this is also possible, isn't it? So therefore, option 1 is the only correct choice here.